Okay, it's a CNC dude here in south of Tampa Bay, Florida, Sarasota, Florida, Suncoast Technical College. And I just got done doing a quick setup, virtual setup. We call this a 2-vice setup and 2 operations. I installed these vices, these Kurt vices, the same exact vices we have in our VF2 and our TM1 Haas machines. Only they're both blue, So I wanted to make one green so we could talk about this. So in this setup here, we got 2 vices. I'm going to just turn off the. I'm going to turn off here. I got a lot of stuff going on here. Models. Turn off that body on that side. Oh, it's 2 of them. All right, on this side we have raw material in our step jaws. These are like soft jaws. We make them out of cold rolled 1018 steel or 6061 aluminum. We pre-machine all these holes. So this is like a good shop project. We buy 1x2 bar. We cut off the length, and we cut this notch in here 200 wide by 200 deep. Works for a lot of stuff. You could probably get away with 150 deep or 100 if you try, unless you get those new Mighty Bite jaws. Okay, so raw material, and we're going to put it in the jaws. We're going to be able to machine all the way around here, and in this case we're going to I didn't get time to build one, but we'll put a stop, or you cut a notch in your soft jaw for your location for production machining. Let's turn the model back on. Okay, so inside here is the model, and it's 1-inch material sitting down the 2-inch jaw, and I think I have the stock shifted correctly. I might be a little deep here, but it should clear without hitting the jaw. I might be a little bit off on that, but we'll see. On this side is operation 2, and we'll have extra material, which is on the bottom here on this side. I'm going to work a little bit better on the simulation, but let me re-zero this. Oh, let me play my new mouse. Okay. Bring it in a little bit closer. So we're going to sit on the finished surface underneath there with the notch towards us, because this is the datum. We're flipping it over so the datum is on this side. So this datum and this datum will align with that. And the goal is we're trying to cut off all the extra material from this side, which will be facing up. And let me see if I can shrink some of these things up. So setup 2 would have this, like, some people call it the hat. That's like the remaining material. And we'll have to put a work stop against this side here. So kind of aligning with the Titan setup procedure to be always aligned to the model. So on this side where X, Y, and Z are aligned to the model. Only when you're doing this setup, let me re-zero this. You're gonna edge finder probe this side, edge finder probe that side, but you can't really edge find with this chunk of extra material up here. It's overhanging. So we substitute a 1, 2, 3 block. And then we edge finder probe this side and this side. And then you can either set your tools off of this surface here or the top of the 1, 2, 3 block, which is about up here somewhere, and then shift it down. If you're using a precision block, and this is the dimension on this is 750, if I inspect this right now, measure this surface from here to here, and it says right there 750 tall. That's what we're trying to create. So if you're doing a setup like that and you're setting this as your Z0, your setup is Z0, right? You got to chop your way down here. So on this side, instead of model top, you get and edit this. You want to use, sometimes I use model top in 1 inch, but I would be going stock top. Stock, 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 and the finish line is model top. So you got to know where your stock is, or it's not going to recognize it for roughing. And we're going to do, let me go and edit this here. I'm going to do multiple cuts. So we got geometry, heights, and I've decided to just take a nice round number, 50 thousandths cuts. And we're going both ways. And I'm starting from left to right or right to left. You can play around with this number. And I might play around with the chip thinning later, but this is pretty much a straightforward. And I'm going to do a finishing step that matches the finishing step on this side, so I get exact same finishes on feed rate. And I'm just going to skim 10th thou off, because you could be more aggressive on the rough down, and then when you get to the last cut, we're going to go only 10th thou. We're not going to leave any stock. And I always turn on extend before retract. So if you have if it's not going all the way, you extend before retract, or you'll have to play with some of these numbers. Okay. And then we duplicated the chamfering move from this side and put it down here. So it's tool 1 and tool 3. And we already have all the data, only we need to reassign it to this new geometry, because the geometry is now on this one here. And we use this edge here with the chamfering tools we use. We set the chamfer width to 0 so that it aligns with the chamfer. If we go beyond that, it adds a little bit more. If you're using chamfer with no model chamfer, then you can add a number. That seems to work good for us. All right. All right, let's simulate. And let's hopefully we don't crash into stuff. So you can go in here. We're going to do both jobs at the same time. So let's go in here. We got to check our setup. Setup 1. Oh, why am I? Hey, escape. I was doing that before. Edit. So in your post process, you want to take care of all 3 tabs. You want to name your program number and name what the job is. STC to op. Oops. To op. Okay. Use work coordinate 1. Do not use 0. Even though 0 and 1 do the same thing. If you want to get both operations, you got to have this one is going to be G5401. Okay, get that one is done. Setup number 2, vice number 2. Now we had this already pre-programmed to do separately, so we could leave this in here, and we'll see what it does. But this will be assigned to be G55 or work offset 2. So this is all set to go. So you have to highlight both of these. And now we will do the, and if you want to just shut off the toolpath, we'll just watch simulation only. So now we'll do up here. Oh, let me turn this one on. I think I can get them both. Shift and this one up here and simulate. All right, there we go. Move this out of the way and press play. All right. Goes around. Cutting that side. Now this is what we're really looking at, and your concern is always, am I high enough that I don't hit the job? So if you're using parallels, you have to make sure you get the correct parallel selection. If your part is too deep, you're going to run into the job. And if it's too shallow, it may not hold. It might pull out of there. All right, this is our adaptive roughing. We're contouring, we're finishing the floor, chamfering, spot drilling, sure we've always seen this a million times. Do some tapping. And then we go to this side. You just hit pause for a second. Unfortunately, I can't get the stock to appear on that side. I'll have to work on that. All right, chopping around and then chopper. So to be more efficient, wouldn't be a ton more efficient, but the face mill is already out, and we could just go face mill, face mill. So if you have jobs that you want to make it slightly more efficient, and when you could do the post, you're going to click on this one, click on that one, and hit post process. It says multiple setups. Yep, we do 2 setups. Right here, I make sure you pick my posts. Our posts are in the cloud. Right up here, setup, use cloud post. We only have a couple here. We have a demo here for horizontal. We have a 4th axis, next gen control, the older classic controls, and our ST10 lathe. So we're using the classic control. Programs already numbered, comments already done, and we're going to reorder to minimize tool changes. And hit post. And we're going to create a file. And if you know anything about G-code, I'll bring this over here. Ooh, what the heck happened? Let's try that again. Post. Multiple. We do take the reorder off and hit post. Save. Already exists. Alright, so there's our code here. We modified it so we have a school name, a timestamp, and a simpler tool list here with just tool numbers, size, and description. And the operation. So operation 1, 2, and I'm going to hit Control End. That'll get you to the end of the file. And the last one, this is G55 for the chamfer, and this is G55 for the face mill on the right side. So in this case, it's going right there. There's your cut moves right there. We're at Z210, Z160, Z111, Z060, and then 10 thou. And on this one, and right here it goes to Z0, and then the feed rate slows down right there to 25. And we moved our coolant so it shuts off before it goes home to the G53. So let's see if we can post with reordering tools. All right, hit post, save, yes, and okay. We can't demo it, but right here, tool 1, G54, does its thing, shuts the coolant off, goes home, and then switches work coordinates and goes to this work coordinate. You know, it's the same positioning moves, but a different coordinate from home. That's why they call it work offset. How do you get to work? And this is going to cut the other side, so you're more efficient, less tool changes. And then everything, and then when the chamfer mill's out, it's going to go chamfer the other side, which makes the other one done. So as this job goes along, you're going to put in raw material on this side, and you're going to take the finished part from this side and load it on this side. Shut both vices, cycle start, and it's going to make 2 parts at once. Now we can get really deep into this and have like 4 vices or double vices. You can do 2 roughing ops, 2 finishing ops. It's kind of like, you know, you can just keep on adding on from there. But this is your typical 2 operation job right here. And imagine the setup time, and if you had to make all of these, 50 of these, and you only have 1 vice, and you got to do 50 of these, and if there's any mistakes, you might end up with 50 bad parts, and you won't know till you get to this side. So at least you get 1 complete part, and for your first article inspection, and it's a go, and then you just run them off. And up here is machining time. So right here it's a a little over 6 minute cycle time. So, and it goes right here, tool change time, machining time, and you could build a lot of stuff into this. So you can gain a little more time. So if you had double vices, that'd be like 12 minutes, or you get 8 parts an hour out of this. So okay, that's my quickie, my double vice simulation. And let me, I feel like playing some more here. I don't think I had on my setup the fixture identified right here, fixture. So this is going to be, I'm going to identify this and this right there. So all I want to know is where the fixture is for collision detection. So on this side, I'm going to do the same thing, and I'm going to call it this and that. Oh, you picked all three. I don't want all three. Oh, wait a minute. Model is that one. That's correct. Fixture is this one. This one. This one. Yeah, okay. So we go back to here, and we do, let's just do simulate one. Simulate. And you put here stop on collision, and if it hits something, it's going to turn red and actually stop. All right, pull this out of the way, zoom up a little bit, and hit play. All right, so it makes it. We're running close there, but it makes it. Let's go right there. Got a problem. Running a little bit too close. I see a little bit of a feather edge there, so let's go and look at this, right? Yeah. All right, that was this contouring cut right here, edit, heights. We use model bottom and 10,000s. Okay. Let's measure. So if I took a caliper and measured from the top of the material down here, I need to have 760 thousandths of material. Let me see if I can measure virtually. So from here to here. Nope, sorry, I'm measuring the wrong thing. So that's 800, but so we have enough room material-wise. I would say our setup for our Z is in the wrong position. We're buried too deep in this thing. So our Z0 is, oh, hold on a second, is right there. So we need to raise the part, or shift the offset up a little bit. So if you're in your work offset, you're probing the top and you overshifted, you've actually made it so this whole model is deeper. Okay, let's go in, see if I can fix this thing here. I gotta go back in design. Let me see. Getting pretty busy here. All right, body 1. I'm going to move it up like, oh, let's go 0.025. And hit OK. All right. Looks better, right? Looks like we're above there. So let's measure from here, top of this, to the top of the face. Let's see if I can actually click on that. Am I getting it? No, I don't think I am. Let's measure again, inspect, measure, and oh, wrong area. Escape, measure from top to there. 20 thousandths. That's kind of like what Titan says. So this should work out good. let's go back to manufacture. And okay, we got to regenerate all these operations again. All right, regenerate. We're still aligned to the model because that was our orientation. We just moved the model, right? And I'm going to reshift this one just to fix it. All right, let's do a simulate. And if you want to jump ahead of operations, you just hit the next operation. All right, so this will be the roughing operation, which we know cleared. And now we're going to hit play to do the contouring. This is where we had the crash. And now we're clear. We shifted our offset virtually. All right, everything should be fine now. Yeah, so you got to be thinking about where the part is and how your setup's going to work so you can machine it without having to kill your tools or your jaws. Now, if you use soft jaws and if you just babied into that, it would probably be fine. Part would hold in, you'd have a little skim mark on there, and it probably would still be usable. But if it ends up doing a big railroad track down here, then you probably have to remachine the top and recut the jaw a little bit deeper, because the good thing about the soft jaws is they're reusable. So, okay. I took enough of your time. See you later.